All right, let's go ahead and look at a couple just review problems. I'm going to go through them kind of quickly here, just kind of a review from last lesson. So remember, with elimination, we are just adding down when we have opposites, like 3y and negative 3y. So 2x and negative x makes a single positive 1x. 3y, negative 3y eliminate. Negative 12 and positive 18 added down to makes positive 6. So I just get x equals 6 for this one. Okay, then I need a y to go with it. So I take that x value of 6 and plug it in. So I choose one of my two equations. I'll pick the top one because there aren't negatives. So 2 times the x value just figured out is 6 plus 3y equals negative 12. 2 times 6 is 12. So opposite operation would be subtract 12. So 3y equals negative 24. Divide by 3. And y equals negative 8. So then I have an x and a y. 6, negative 8 is my final answer. Okay. Let's look at one that's a little more complicated. Okay. What happens when we don't have negatives, or excuse me, opposites? So remember, when we don't have opposites, we have to multiply in order to create opposites. Turning 5 and 7, or turning a 5 into a 7 doesn't sound very easy to me. Turning a 1 into a 3 sounds a little bit easier, okay? Since this one is negative 3, I want this one to be positive 3. So this is already negative 1. In order to turn it into a positive 3, I'm going to have to multiply it by negative 3, right? Because negative 3 times negative 1 would be positive 3. And remember, you have to multiply the whole equation. Okay, so now rewriting, negative 3 times negative x is positive 3x. Negative 3 times 5y is minus 15y. And negative 3 times negative 16 is positive 348. Okay, second equation didn't change. So now I'm ready to add down. Okay, so the last equation had, or the last problem had opposites already. This one did not, so we had to multiply to create opposites. So now 3x and negative 3x eliminate. Negative 15y and 7y makes negative 8y. 48 minus 8 is 40. Divide by negative 8. And we end up with y equals negative 5. Okay, then I need an x value to go with it. So I plug my negative 5y in. I'll pick the top equation. So I have negative x plus 5y, I know is negative 5, equals negative 16. So negative x, 5 times negative 5 is a negative 25. So I need to add 25. So negative x equals 9. Divide by the negative 1, and x equals negative 9. So negative 9, negative 5 is my answer there. All right, so let's check out some problems that are a little more challenging. Okay, so this lesson is just kind of using the same concept, but just taking it up a notch, okay? So with problem 5 that we're looking at here, we don't see any opposites, so we want to create opposites. The only problem is there's nothing I can multiply 2 by to make it a 7 without using a decimal, and we don't want to do that. And then if I look at the y's, there's nothing I can multiply 2 by to make it a 3. Okay, so regardless of if we multiply here or here, we're not going to be able to make opposites. So what our solution is to multiply both of the equations, okay? So if you think about 7 and 2, I could make 7 and 2 both into 14, right? With 2 and 3, I can make them both into 6. I like this y option because they're already positive and negative, right? So I want them to be 6 and negative 6, and they already have the positive and negative signs on them, okay? So the top equation, in order to make a 2 into 6, I multiply by 3. The bottom equation, in order to make a 3 into 6, I multiply by 2. So now I'm rewriting both equations. Okay, so 3 times 7x is 21x. 3 times 2y is plus 6y. 3 times 2 on the other side of the equal sign is 6. Now my second equation, 2 times 2x is 4x. 2 times negative 3y is negative 6y. And 2 times negative 28 is negative, what would that be, 56? Yep. So now I have opposites and I'm ready to add down. Okay. So you can see through my process of multiplying both equations, I created things that could be eliminated. Okay, so now let's add down. So 21x, 4x makes 25x. 6y and negative 6y eliminate, which is what I wanted. And then on the other side of the equation, 6 and negative 56 makes negative 50. So then I divide by 25. X equals negative 2. Plug it back into one of my two original equations. Let's do the top. So 7 times x, I just figured out as negative 2, plus 2y equals positive 2. So 7 times negative 2 is negative 14. So I add it. So 2y, it's not a very good y. There you go. 2y equals 16. Divide by 2, and y equals 8. So my ordered pair is negative 2, comma 8. All right, let's look at one more here, number 6. Okay, so again, I can't multiply either one of them easily, so I'm going to have to multiply both equations. So I could match up the x's, what would that be, 24, right? I could make it both into 24s, or I can make both of these into 6s. 6s sound a little better to me, especially because they're already positive and negative, okay? So that means I need to multiply the top one to make it a 6. I would have to multiply by 3. In order to make the bottom y term negative 6, I would have to multiply by 2. Okay, let's rewrite here. So we have 9x plus 6y equals 12. When I multiply that, 3 in. Bottom equation, when I multiply 2 in, I get 16x minus 6y equals negative 12. And now I am ready to add down. So 9x and 16x makes 25x. 6y and negative 6y eliminate. On the other side, 12 and negative 12 make 0. So then, to get x by itself, I divide by 25. And I end up with x equals 0, because 0 times divided by anything is still 0. So then I plug that in to find my y value. I'll pick the top equation, so 3 times the x value of 0 just found, plus 2y equals 4. Anything times 0 is just 0, so that term's gone. So I just need to divide by 2, and I have y equals 2. So then my ordered pair answer is 0, comma 2. Okay? So those are the most complicated type. When you can't just multiply one equation by anything, you got to multiply both equations. Okay, so that's that. All right, so go ahead and let's see, it's on the next page. Let's go to the next page. Go ahead and pause the video and let's try number 7 and number 10, and then play the video when you're ready. All right, so let's look at 7.
You're going to get it, Christian.
All right, so on 7, nothing I can multiply just one equation by. So I have to multiply both equations. So the x's I can make into 15 and negative 15. The y's I can make into 18 and negative 18. I'll go ahead and do x's since they're already positive negative. So that would mean I would multiply the top equation by 3 and the bottom equation by 5. So now rewriting, I have negative 15x plus 27y equals negative 26. Bottom equation is going to be 15x plus 10y equals, what would that be, 110. Now I'm ready to add down. X's eliminate. 27y and 10y makes 37y. And then negative 26 and 110 would be, what, 84? So then divide by 37, and it gives me y equals 2. Okay, I need the x value to go with it. I'll pick the bottom equation because I don't like negatives. So 3x plus 2 times y is 2 equals 22. 2 times 2 is 4. So I subtract 4 from both sides. So 3x equals 18. Divide by 3, and x equals 6. So my ordered pair is 6, 2. Okay. And then, what was the other one I told you to do? 10. Okay. So on 10, looks like I could do 2 and 3 to make them 6. Or I could do 3 and 4 to make them 12. Neither one of them is already positive, negative, so it doesn't really matter what your preference is. I'll just do the x's. So here I do have a decision to make. So I need to make one of them negative. So I know in order to make them 6 and 6, I would have to multiply the top by 3 and the bottom by 2. But remember, I don't want them to be 6x and 6x. I want them to be 6x and negative 6x. So you just got to choose one of them. I'll just make the bottom one negative. Okay? So now I'm ready to add down. So I get 6x plus 9y equals negative 3 when I multiply out the top equation. Okay, bottom equation, I get negative 6x minus 8y equals a positive 8. And now I have opposites, now I'm ready to add down. So the x's eliminate. 9 and negative 8 makes 1y. And then negative 3 and 8 makes positive 5. So we just end up with y equals 5. So then I need an x value to go with it. I'll use the top equation. So 2x plus 3 times y is 5 equals negative 1. 3 times 5 is 15. Okay, so then solving this, I subtract 15 from both sides. So I get 2x equals negative 16. Divide by 2. And x is negative 8. So then ordered pair, negative 8, comma 5. There we go. Okay. So now we have a couple word problems. Okay. So these are honestly probably the most challenging thing you do all semester. Okay, but stick with me and we'll get through it, I promise. Okay. All right, so it tells us a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Okay. So that seems like a total number of vehicles. Okay. A receives 5 large vans and 2 small vans for a total cost of $235,000. B, let's do a different color. B receives 2 large vans and 3 small vans for a total cost of $160,000. Then it asks me, what is the cost? What is the cost of each type? Okay. All right. Okay. So variables. Okay. That's what we need to know. So the 2 things that we need to know here are, let's say, let's see, we have large vans and small vans. Let's just call X the cost per large van. And let's say Y is the cost per small van. Okay, let's go ahead and write our equations. So let's write one equation for location A and one equation for location B. Okay, so for location A, it looks like they have 5 large vans, and remember large vans is X, plus 2 small vans, and 2 small vans is Y, and their total was $235,000. Okay, then my second equation for location B, they have 2 large vans plus 3 small vans, and their total cost is $160,000. Okay, so at that point, I can go ahead and match up my opposites, add down, do the whole 9 yards. For the sake of time, since this video is already a little bit long, I guess it's not that long. We're not gonna solve it, okay? But on your practice, I will expect you to solve it, okay? On the try this problem, go ahead and pause the video, write down your variables, write down your equations, and then you can go and play the video when you're ready for me. Okay, so it says one night a theater sold 548 movie tickets. An adult ticket was $650, a child's ticket was $350, and it says the theater made $2,881, and it tells us there were 548 sold. So then it says how many of each kind were sold. Okay, so let's see, we have adult tickets and children's tickets. So let's say X equals the price per adult, and Y is the cost per child. Okay, so now let's go ahead and write our system. So this one's a little bit different than the number 11 that we did. Number 11 had two different companies or two different locations that were getting things. So we had one for each location. We really have to pay attention here to our two big totals. So our two big totals are 548 and 2,881. Okay, so with each total we get a separate equation. So 548 is a number of tickets. Okay, ooh, you know what, I messed something up. So let me point something out here because I made a mistake. So right here it already tells us the cost of the children in adult tickets, right? We want to know how many of each. So I want to actually get rid of right here on my variables. It shouldn't be the cost and cost. It should be the number of adults and the number of children. All right, so now that that's fixed, sorry about that. Now we can go back to our two totals. So 548 is a total number of people or a total number of tickets. So that 548 is equal to adults plus children, right? There's no other options. So adults would be X plus children would be Y. Okay, so that's my simple equation. My more complicated equation is money. So $2,881 is the amount of money, okay? And we know the amount of money per ticket, but we don't know how many tickets. So adults were $6.50, so $6.50 per adult, that's X, plus children's are $3.50, so $3.50 Y. Okay, so this equation right here is all about the number of tickets. This is all about the money. Okay, so you got to be careful. Keep number of tickets with number of tickets. Keep money with money.